We're now going to work through two examples where we are going to evaluate a definite integral using geometry. A definite integral can sometimes be solved by interpreting it as an area or areas under a curve. In both of these examples, we are going to evaluate the integral by interpreting it in terms of areas. In our first example, we have the integral from 0 to 10 of the absolute value of x minus 5 dx. The absolute value of x minus 5 is the function that we're going to be integrating, and we're going to start by graphing this function. To make things easier, I'm going to write down the definition for the absolute value of x. It is a piecewise function, and it's equal to x when x is greater than or equal to 0, and then it's equal to minus x when x is less than 0. We can then write down that the absolute value of x minus 5 using the same pattern is x minus 5 when x is greater than or equal to 5, and then minus the quantity x minus 5 when x is less than 5. We are integrating our function from 0 to 10, so let's find out what our function is equal to at 0 and at 10. When x is equal to 0, the absolute value of x minus 5 is equal to the absolute value of minus 5, which is 5. And then when x is equal to 10, the absolute value of x minus 5 is just equal to 5. Let's also find what this function is equal to in the middle, where our function changes. So we get x minus 5 absolute value is just equal to 0. Now let's go over here to our graph and let's plot these points. When x is equal to 0, our function is equal to 5. And then when x is equal to 10, it's equal to 5. And when x is equal to 5, it's equal to 0. So our graph looks like this, which is what we would expect when we graph an absolute value function. Let's put here that this is 5, and then this is 10. Now we can interpret our integral as the area under these two triangles, this triangle and that triangle. So our area is 1/2 the base times the height for each triangle. We have two of them. So our area is 1/2 our first base, which is 5, times our height, which is 5. And then our next triangle is the same, 1/2 5 times 5. You can also think about putting these two triangles together, and then you would just have a rectangle with base 5 and height 5. This gives us an answer of 25. What we did was much easier than having to substitute our piecewise function in and integrate it. Let's now look at our second example. In this example, we are integrating from minus 5 to 0, and our function is 1 plus the square root of 25 minus x squared. We're going to start by breaking up this integral into two pieces because both of the functions that we are integrating have different areas. This is equal to the integral from minus 5 to 0 of 1 times dx plus the integral from minus 5 to 0 of the square root of 25 minus x squared dx. Let's start by looking at the integral from minus 5 to 0 of 1 times dx. Our function is equal to 1, so up here on our graph, I am going to draw the line y is equal to 1. And we're going to go from minus 5 to 0. Our height is equal to 1, and our width is equal to 5. So we can say that our integral is equal to our area, and that's our base times our height. Our base is 5, and our height is 1, so we get an answer of 5. Let's highlight this because that's part of our answer. Let's now look at our second integral. This one is definitely harder. We have the square root of 25 minus x squared dx. Our f of x is the square root of 25 minus x squared. And I think this is easier if we think about this as y. We can then square both sides and we get 25 minus x squared is equal to y squared. So we have 25 is equal to x squared plus y squared. So this is a circle with radius equal to 5. Notice now that we are integrating from minus 5 to 0. So we actually have 1/4 of a circle. And that circle looks like this, where this point is minus 5, and this point up here is 5, and that's 0. So we can say that our integral is our area, and it's 1/4 our area, which is pi r squared. So this is 1/4 times pi times 5 squared. And this gives us an answer of 25 over 4 times pi. Now all we have to do is add both of these up to get our final answer. So let's write down that our answer is going to be our first area, 5, plus our second area, which is 25 over 4 times pi. And there's our answer.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.